In this video, we're going to look at u substitutions with a root, a u substitution with with two substitutions, which will be kind of interesting, as well as a u substitution with a definite integral. All these problems come from our notes packet, and then at that point, you should continue on in your packet and make sure you have all the problems before you do that take-home quiz. A u substitution with a root. The reason I put this one there is just a hint at that idea of how to do a u substitution with a root. U equals root x minus 1. Du is equal to something. And I'm doing u equals root x minus 1 because that's the composite function. That's the function within the function, and its derivative is also within the function, but that might be a little bit harder for people to see. When I do the derivative of root x, or when you do the derivative of root x, you might be doing this. The derivative of root x is the derivative of x to the 1/2, and then that means it's going to be 1/2 x to the negative 1/2, and then you might do a rewrite, so you get 1 over 2 root x. And that's great. That's exactly what I want you to do. But I also want you to grow in this regard, and I prefer that you jump right here, that the derivative of root x is 1 over 2 root x, and that's a flashcard. That's something that you just want to know so you don't have to do those extra steps. I'm going to erase this, and I'm going to go back to the problem at hand using that new information. U equals root x minus 1, so du is equal to 1 over 2 root x dx. Now, I don't know how you have been doing your balancing, your compensation here, but I'm noticing that there is not a 2 in the original integral, so I'm going to put a 2 there. That's not a very clean 2. I'm going to put a 2 here on the bottom, but then I'm also putting a 2 on the top. And now I'm going to do my rewrite. My rewrite is going to look something like 2, that same red 2 on the outside, and then the integral, and this is where you're going to kind of be that accountant. I'm going to go ahead and do root x minus 1, that is u, so that's going to be u squared, and then the 2 root x dx, the 1 over 2 root x dx, that all was going to be du, so this is u squared du. And that's the rewrite for it, and now I can go ahead and integrate, so I got 2 times the integral of u squared is u cubed over 3 plus c. And then just make sure that you end back where you wanted to end back where you kind of started with x's. So this final part is going to be 2 times root x minus 1 to the third over 3 plus c. And if I was to reiterate anything on this problem, the big reason I chose this problem is just to recognize that the derivative of root x is 1 over 2 root x moving forward. Number 6, this is going to be on page 20 of your packet, so make sure you pause to get caught up with where we're going. This u substitution is going to be unique because the derivative of the u that I'm going to choose is not in the integral. And yet, you can still do the problem. So what I'm going to do is I'm going to take this composite part, I'm going to set a u here, equal to that part. So u is equal just x minus 1, not x minus 1 to the 5th. And when I do du, I get dx. Now that's going to be confusing because when I write the integral here, I'm going to get u to the 5th. But notice for the accounting piece, there's still this extra part that is not accounted for here. So I'm just going to put that here as x plus 3, and I'm going to switch out the du and the dx, because those were equivalent. Du is equal to dx, so those are equivalent here. And I think I said I was going to do that, but it never actually did it, so let me change that. Okay, so we have du. And until you're in multivariable calculus, you are not allowed to integrate 2 variables in this course. You should only have 1 variable. Everything should be in terms of u. So how do we get that u? How do we get rid of that x plus 3? Because that x, and the plus 3 is not the problem. This x is the problem. How do I get rid of that? And and if you hear any kind of rummaging about, that's because my daughter is right here and she's kind of rummaging around. U equals x minus 1 is going to be the key. A lot of students write this down and kind of move forward from it and never really look back at it, and we haven't had to until now. This u equals x minus 1 can be used to solve for x, so that way our new integral will be entirely in terms of u. So what is x here? X is equal to u plus 1. Okay, so now when I rewrite my integral, the u to the 5th stayed. There's no extra compensation that I had to do there. And then I'm going to plug in for u, x plus, for x, I'm going to plug in u plus 1. So it's going to be u plus 1, and then plus the 3 that was still there, and then a du. Notice now that my entire integral is going to be in terms of u, which is perfect. So I'm going to drop the colors here, and now I'm ready to go with it. I have u to the 5th times u plus 4 du. And what next? What do I do next? Now I'm going to distribute. I'm doing the math that's right in front of me here. I can't integrate u to the 5th yet because it's multiplied by u plus 4. I told you guys in the beginning of u subs, I'm not allowed to actually distribute the u to the 5th into u and plus 4. I have to just distribute and do term-by-term integration. So the next part I'm going to do is just multiply these out. So this is going to be equal to the integral of u to the 6th plus 4u to the 5th all du. And now I can integrate, and this integral is going to look something like u to the 7th over 7 plus 4u to the 6th over 6 plus c, the constant of integration. And now switch out the x's and you got your answer. And u was x minus 1, so our final part here, and I'm writing small sort of, x minus 1 to the 7th over 7 plus 4/6, or 2/3 if you wanted, 2x minus 1 to the 3, I'm going to run out of room, over 3, and then finally, I apologize for this, and then that plus c. And that's your answer. And again, this problem was unique because we never, ever, ever had to solve for x before, and we solve for x. It's called a double substitution. We had to do this double substitution because when we made our initial one, we still had an x remaining. And we're not allowed to have that. All of our part integral should be in terms of u. Okay, next. Last one. Did I just write it? I'm not allowed to write it, am I? I'm going to get rid of x. Okay, last problem here. No, last problem. No, last problem. A definite integral. When I taught you guys about definite integrals, I reminded you guys that when we write these limits of integration, they're in terms of x. So when I'm going to do this integration, I know that x equals 1 and x equals 4. But the problem is, when I have a u substitution, I can't use, similar to what I just did before, I can't have x's and u's in the same integral. I've got to have all u's or all x's, unless you're in multivariable calc, which you're not in yet. So how do I do a u substitution with a definite integral is the question. Let's do a u sub on root x plus 1. Let's do a du as 1 over 2 root x, because we went over that in the first problem. The derivative of root x is a note card you're going to put now, and the derivative of root x is 1 over 2 root x. If you're not sure about that, you'll need to pause the video to do the work on your side and make sure that that's true. I'm doing my compensation here, and I'm checking the accounting here. I got a dx, so that's good. I have a root x on the bottom, and that's great. But I don't have this 2 here, so I have to compensate for that. I'm putting a 2 on the bottom, but I also have to put a 2 on the top and outside. I do have the root x plus 1, so that's good to go. I'm just going to add another color here so that way we can see that. I do have a root x plus 1, and that's there. So I'm going to do a rewrite on this integral. This integral is now going to be 2 times the integral of, I'm not going to put the limits of integration just yet, 1 over, let's see, the 2 root x on the bottom with a dx on top was all du. I'm going to repeat that. This 2 root x is on the bottom already, and this dx is on the top, and I have both, so all of those amount to du. And then the other part, the root x plus 1, is going to be u, so now it's u squared. I can't put x equals 1 and x equals 4. I need to change these now to u, because I have an integral in terms of u. So I'm just going to write here, change limits of integration. And I apologize for my handwriting here. I know this is terrible. All right, change limits of integration to u's. Okay, so how do we change that limit of integration? Great question. We have to use this equation again. That equation is key to getting everything in our integral in terms of u. So let's do it. We're going to do u of, I'm going to take this x value, and I'm going to plug in 1 for it. So I'm going to do u of 1. U of 1 is going to be root of 1 plus 1, and root of 1 is 1 plus 1. 1 plus 1 is? B said 2, so it's 2. And now let's go on and do u of 4. Let's do u of 4. And u of 4 is going to be, again, I'm using this equation twice here because I have two limits of integration. U of 4 is going to be, and I'm using this 4, by the way, in case you weren't sure. I'm going to go and do u of 4 is equal to the square root of 4 plus 1. And the square root of 4 is 2. And 2 plus 1 is 3. That's what my daughter said, so I'm going to go with what she said. So we have u of 4 is 3. And now I'm putting those in place of each one of them. So where there was a 1 before, I'm now putting u equals 2. Equals 2. Oh boy, that was not clean. Hold on just a second here. U equals 2. And where there was 4, I'm now putting u equals 3. And now I have my entire integral in terms of what I want, and what I want is going to be in terms of u altogether. Now I'm ready to do the integration part. This was all a rewrites part. So next I'm going to go and just drop all the colors here. I have 2 times the integral of u equals 2. I think that's a u equals 2. U equals 2 to u equals 3. It has 1 over u squared here. I'm going to do u to the negative 2, just so I can integrate that with the reverse power rule. This is now going to be equal to 2 times u to the negative 1 divided by negative 1 and evaluated from u equals 2 to u equals 3. At this point, students do a couple things. Some students switch back to x, but you don't have to. You already accounted for all the x's. So the shortest way to do the problem is keep everything in terms of u, and that value will be the same value as the original integral with x's. And I encourage you to check both on the calculator once the video ends. So we have 2 times 3 to the negative 1. We're going to do top minus bottom. 2 times 3 to the negative 1 divided by negative 1 minus 2 times 2 to the negative 1. That's the bottom part, divided by negative 1. I'm going to go super slow through the calculation. I think I said I go as slow through the calculation like an injured turtle. So now I'm going to go ahead and do, oh boy, I think this is negative 2 over 3. And I believe this is going to be negative 2 over 2, plus the 2 over 2. You can check the math on that, make sure it's correct. And then it's 1 minus 2/3, which I believe is 1/3. And again, I encourage you to please, once this video is done, check this integral and see if this integral, oh, that looks beautiful, baby, and see if this integral matches the one that we started with. Because if I did all the work right, it should. If I didn't do all the work right, well, I'll probably get some text about it because I made mistakes. Hope this video was helpful. Thank you for watching. And